Welcome to part 6 of the GoPxL first-time user video. We will demonstrate how to use the new feature of arrays, batching, and aggregation when combining measurement tools. To get the most out of these videos, download the following links to follow along with this video. Arrays as outputs. GoPxL allows you to create array outputs, meaning that you are able to bundle data together into a single output. An array output may be created from a multi-layer scan, like the example from the previous GoPxL video part 4, or you can create an array output from a measurement tool. In this video, we will use the surface blob as an example. There are often a lot of blob outputs when working with the surface blob tool, so enabling array output will bundle all of your blob surface outputs together. Or we could choose to bundle area outputs together or center X point outputs together. Really, it's your choice. So let's get started. First step, open GoPxL Manager from the Windows Apps menu if GoPxL is not already running. Next, let's upload the GPREC file GoPxL G2520 RAM. In this case, I have one with no tools. You should see, like I have on my screen, a RAM board. Next, let's go to the Tools page. And we're going to add the surface blob tool. So let's go to the search menu here and put in blob. There's our surface blob tool. You can grab it and you can drag it over, or you can double click to add the tool. In the tool configuration, let's go down to the parameters. And let's open up the measurement regions menu. So anything in blue here will be an extra menu. And what we want to do is we want to enable our measurement region, just because we're going to focus on the top 2 embedded chips in this RAM board. So let's make our region of interest this big here. I'm going to focus in a touch. And I'm going to make my yellow region of interest box this big here, just focusing on those top 2 embedded chips. Let's go back to our parameters panel. In the parameters panel, let's include null points if it's not already on, and let's adjust the height threshold to 0.8 millimeters. 0.8, as you can see, we're just walking down the parameters menu. You can see already that this is starting to take shape. We have most of those embedded chips, but not all of them. So let's keep adjusting our settings. Let's set our kernel filters to 0 points. Let's zero these out. There's no need to adjust or filter any kernels for this scan. Let's keep it as close to the original scan as possible. Let's set our hierarchy to external and internal blobs. What this allows is to find basically blobs inside of blobs, not just looking for one big outline, but we're also allowing for details or blobs inside. Let's adjust the max area to 100 millimeters squared. I've done the measurements for you. I know these nominals, and let's now set our minimum area to 0.3 millimeters squared. There we go. So using these settings to create blobs that outline the embedded chips in the RAM board, this should result in about 26 blobs or so. If your region of interest box is a little bit bigger and you're picking up there's about 5 tiny little chips at the bottom, you may get 31. Let's make this small enough and stick with 26. Let's go down to the bottom of the parameters panel. Let's set the number of blob outputs to 10. I know that we have 26 outputs in total. However, when I set my blob outputs to 10, what's going to happen is if you scroll down your outputs, now we have 10 copies of our measurements. So you can see that we have all of the measurements that the blob tool provides: center X, center Y, width, length, area, all of that. We have it for blob 1, blob 2, blob 3, blob 4, all the way to blob 10. And just so you know, when we're looking at blob 1 to 10, you can order your blobs. Right now we have them ordered from large to small. You can order your blobs X increasing, Y increasing, kind of any direction that you prefer. Since we have all of these open, what I'm going to do is I'm going to scroll down all the way down to the bottom of my outputs where I have my surface, and I'm going to enable surface 1 You can see that surface has popped up. I'm also going to enable surface 2. So now you can see that both of those surfaces will show up. Doing this way, you can see we're only able to view one blob surface output at a time. If we want to bundle all 10 surface outputs together to view at once, this is where we would use the array output function. So let's scroll back up to the parameters panel. There is an enable array output selection. So this will be under the parameters. We can check that. Note how the surface blob outputs, the two that we have listed, have changed to a single measurement output for all 10 blobs. In the outputs panel, let's enable the area outputs, shall we? So now you can see all 26 blobs found are present here. If I hover over the output, we can see the area of blob 1 or blob 0 all the way to 26 in order of size. To view each blob area one by one, you will have to open the displayed outputs. So under the display viewer, there is a displayed outputs menu. Here we have our surface blob area. And if I open this up, we can either select all, and you can see all areas are highlighted in red, or if I select surface blob area 1, we can see that that one particular is highlighted in red. All the rest are highlighted in blue. The last step, and this is very important, is to enable blob surface output for the next tool for us to use. So down at the bottom of our outputs, let's enable blob surface. And what that's going to do is just populate all of the surface outputs, because we're going to use that for our next tool. Batching or aggregating arrays as inputs. Now that we have created an array output, let's turn to using array as an input. There are two ways to use an array as an input: batching or aggregating. Batching takes an arrayed output and processes each array element separately. Aggregating takes the entire arrayed output as a single unified item. So let's take a closer look at batching using the surface blob array output as an example. We will use surface bounding box to find the width of individual blobs, all of these blobs here, contained in the array output. Let's add the surface bounding box tool. Again, let's go to our search function. I'm going to input bounding, and in this case, I'm just going to double click, and that will add it below the surface blob tool. It should automatically connect. I will open up my surface bounding box, and you should see that my surface input has automatically connected to that blob surface output that we just enabled. In the surface bounding box tool configuration, in the inputs panel, I am going to turn on enable batching. So at the very top of our tool configuration, let's turn on enable batching. Note that the default outputs of surface bounding box, so our X, our Y, our Z center points, down below here, change from a single measurement to multiple measurements. So before we would have just a single area, single item that is being measured. Now we are measuring all 26 blobs. For example, if we hover over the X center point output, you will see the full list of blobs contained in the array. Now let's go down to the outputs panel. Let's go and turn on our width measurement output by checking the box. And if we open the displayed outputs, again, that's below our display viewer, let's select surface bounding box 1 width. There we are. Let's click on the all drop-down menu, and let's select blob 0. This will highlight the width of only that single blob in the array. However, all blobs in the array are still being recognized and measured. So let's set this bounding box 1 width in our display viewer back to all. Now we're looking at the width of all the blobs. Now let's try aggregating an array input. Aggregation is useful in cases where you have multiple sensors and want to process the multi-piece data set as a whole. For example, aggregating arrayed raw outputs. This will allow certain measurements to be performed on a collection of raw profiles or surfaces. This is mainly used for passing multi-sensor datasets to 6 DOF tools. In this example, we will use image data from a 4-sensor ring layout. In this case, let's load ring layout target.gprec. Let's go ahead and upload this ring layout target. We can discard this previous one. Now let's take a look at what this is. So here is our 4 sensors taking an image of a target. After we have set our tools in place, it will assemble all of these. Right now it is just combination. It has all 4 sensors, but the image has not been combined or aligned correctly. So let's navigate to the tools page. Let's select new sensor 1. Let's expand the displayed outputs under the display viewer. And let's select 0 from the replay new sensor 1, sensor 0 to 3. Here you can see the surface data from each of the 4 sensors individually by selecting different sensors in the displayed outputs menu. Select the Surface Mesh 1 tool in the Active Tools menu. That's the last tool down here. In the Parameters panel, we will have to open the Sensors drop-down menu. To be able to do this, we will have to disable processing. So with processing enabled, that means the entire file set is being processed or combined. So we want to stop that. We're not enabling the processing. By unchecking that, now we're able to adjust our settings a little more. Let's open up that Sensors drop-down menu. In the sensor parameters, select sensor 1. Now let's open up the sensor 1 drop-down menu. And let's ensure that the transformation values saved in that GPRec file have loaded correctly. As long as you are not seeing zeros, as long as there is some kind of value or transformation that is saved in here, then this should work just fine. All of this value should be saved correctly. Now, seeing that sensor 1 transformation values have loaded correctly, I can assume all sensors are now aligned. If I really want to, I can look at sensor number 2. I see the values are saved in there. Sensor number 3, they should be just fine. All of those values should be saved. Knowing that all of these values were saved, at the top of the parameters panel, now I can recheck or re-enable processing. I'm going to check that box. If I expand the Surface Mesh 1 tool panel, I can click on Mesh Output to be able to see the transformed surface data from all 4 sensors. There we go. All of those transformation values have been put into place. What looked like a jigsaw puzzle now is a perfectly transformed target of a layout of 4 sensors. In this case, there is no benefit to isolating the scan from each sensor. We want to measure all the meshed image as a whole, so we do not turn on enable batching. This is a good case for aggregation. Finally, here's the full list of GoPxL measurement tools that are capable of aggregating array inputs. For more information, please look to the GoPxL for G2 user manual found on LMI3D.com. For further assistance, please contact support@lmi3d.com. Thank you for watching.